as far as I understand this new hypothesis that we're doing, this ANOVA hypothesis, it seems to be that it's either equal or it is not. One of them is not equal.
Right.
Something like, I had a really good way of explaining this. I understood it. They're either all equal or one of them is not equal
Right.
to the others. Right?
Right.
Okay. Well, good. Then I got that right. And the assumptions for the ANOVA are that it's a normal sample and also that something, I might have forgotten it. Oh, yeah. That the p-value is, no,
The
the variances are equal for each group.
Yeah. Got it.
That's what it was. Okay. Cool. Cool. And then how is it different from everything else? When we were comparing all the other ones, if one of them wasn't equal to the other, then we didn't discount it. But this one, if there's even one that's not equal to the rest, then you discount it as the null. You discount the null. You reject the null. There we go.
Right.
Right?
Right.
Cool. All right. Let's.
Sorry, I'm trying to like close. I have a bunch of Excel stuff open.
Were you talking to me?
Yes.
I did not hear you. Sorry.
Well, I was kind of talking to myself too. I was like closing all my Excel files.
Oh. Okay, I got you.
So what number are you on?
All right. Okay, so I have the woman poet thing pulled up. So you tell me if this is right. But I had my newest tutor come today, and he said that what we need to do is you take the mean of all three of them separately, and then you compare it to the mean of all of them together, right?
Really?
He never used SPSS though. He used a graphing calculator and he used, that's it. He didn't even use Excel.
Interesting.
So
So why do we need to do that part of it? Like,
that's just what, so I was like, so how would we find out whether or not these are all equal to each other? And he said that the way you do it is you find each of the means individually for like 1, 2, and 3, and then you compare it to the mean of all of them. And if each of them match up to the 1, then the null hypothesis is true. And if one of them is not equal, then it doesn't match up.
Okay, yeah. So when I was watching, that does make sense. When I was watching the supplementary video, it said that like Brother Balls did all of it in SPSS, also did like the box plot and stuff, and you could see like each one of the means or median, you know, you could tell which if one was different. So that does make sense that you said they could do that.
Okay. Well, we can just do it the way that it is in the book. I think he just explains it to me that way because I need it explained in a way that I can understand.
So is he like a specific tutor for stats then?
Say that one more time.
Is this tutor that you have a specific one for stats? Like, is he like specifically for this class?
No, he's just taken stats. I can't find anyone for this class specifically.
But so you went to the math lab and he actually understood what was going on?
Yeah, he used to work at the math lab, and we were at FHE last night, and we were learning about each other, and he's like, I'm the king of math. And I was like, oh, are you the king of stats? And he's like, yes. And I was like, yes! We need to become friends immediately.
That's awesome. That's so good.
So he explained a lot of things to me that I did not really get, but he doesn't understand SPSS. He never used it. He used a graphing calculator. So
that is so crazy.
Downside.
So interesting though. But he'll be able to explain things to you?
Yeah, he'll be able to explain it to me in a way that I can understand. Like, I used to not understand the z-score or level of significance. Like, I could do it. I could plug in the formulas, but I didn't understand what it was or like what I was actually doing. And today he explained it to me, and I was like, oh, some of it makes sense now.
Yeah. Oh, you opened a whole new world. Thank you.
And he's gonna come and help me review for the exam because pretty sure I'm gonna fail that thing.
You are not gonna fail.
Not if I get help and learn. But
He sounds awesome.
yeah, he's a cool guy. He's pretty nice.
Is he attractive?
No.
Dang it.
Yeah, I know. But I made a move, Shuri. You should be proud.
Even if he's not attractive, Martin is pretty attractive here. Let's be real.
No, I made a move on a guy that I do think is cute.
You did?
Yeah.
Are you like hanging out?
Well, kind of. I mean, I'm gonna go over on Sunday and help him do family history. That's how I make a move. You know what I'm talking about?
That's right. That's exactly how you make it.
Oh boy, we're so off topic.
I need some downtime. We just got plans. Well, we got to our new house today.
Oh yeah, you're in your new house, aren't you?
Yeah.
Do you love it? Is it beautiful?
It's beautiful for Kansas City. To put it that way.
Oh man.
Kansas City has some ratchet houses. I'll tell you what. We used to live in like it was a pretty big house in Boise.
Right.
It had like new flooring, new paint. Everything was decorated how I wanted it. My mother-in-law owned the house, and she like put all the updates that I wanted into the house.
Right.
So it was like my house. This house is like it's all right. They put new carpet in it, and they painted the walls, so it looks nice, but it's not.
It was just not there yet.
Yeah. Since we're renting, there's only so much to do. So.
But you'll get it there. You'll get it there. You're awesome.
I'll try. It's just getting settled in.
That's what you have to do with an apartment. I mean, you gotta make it your own, you know?
Yeah, when I first got up to Peoria, Idaho, I had my awesome roommate, and she like just made I don't know, just awesome. She like brought all this stuff to the walls, and all these really cool stuff, and I was like, oh, this is how you make it look awesome.
Say that again.
A really awesome roommate when I first got to Peoria, Idaho. And you know, when you move into your apartment, it's like all like bland and boring.
Yeah, it is.
She brought like all this awesome stuff. She had like movie posters and like just tons of fun stuff to put on the walls.
Shuri, hang on 1 second. I'm gonna go see if I can borrow headphones from somebody because I'm having a hard time hearing.
Probably because I don't have my headphones.
It's probably just because I'm deaf.
No. I don't know where they are. They're probably in the van.
What? What do you mean? I just needed some earphones. I can't hear Shuri. Oh. Nice. I already signed up for the class and it was too late. All right, can you hear me?
Yep.
Ah, that's a lot better. Wonderful.
You can kind of hear me now.
Yes, I can hear you a lot better now.
Did you do the prep worksheet at all?
Did I do the what?
Have you started the preparation worksheet thing?
Yeah.
Prep assignment? Okay.
So Trevor was my tutor, and I decided to just like look at the quiz and just kind of see how I was doing, and I feel pretty good about it, except for the SPS stuff. I didn't feel good about that, but other than that, I was looking at it and I feel pretty good about it. So we could do the quiz and we could go through the preparation quiz or preparation thing assignment afterwards if you want to do that.
That sounds fine.
Cool. Let's do it. Here we go. Here we go. Okay. All right, so number 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. I say true.
That's what I said too.
Nice.
Okay. 4. What requirements need to be checked when performing an ANOVA hypothesis test? I put B and C. Stating that Superman are distributed and Vance distributed.
That is also what I put. Okay, number 5. To check if each group is normally distributed, do the following. Construct construct a scatter plot of the data in each group. Construct a histogram of all the data. Construct a QQ plot for each group. Did you say construct a QQ plot for each group?
Yeah, because that's what we did in the video.
Okay. That's what I said as well.
So number 6. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. That's one I put.
The largest variance is less than 4 times the smallest variance?
Yeah.
Okay.
I
put the last one if each group has the same sample size.
Okay. We assume the variance in each group is the same.
Okay, I guess maybe that would be wrong because just because I have the same sample
Well,
size doesn't
I
mean.
think I just automatically went to that one because that's the one I chose because it was one of the rules that we went over.
Oh, that's right. It was one of those.
I mean, it was in the book that the largest variance is less than 4 times the smallest variance. But also, what confused me a little bit when I watched the supplementary video, he's talking about standard deviations, and it was like he would check the standard deviations to make sure they were like the smaller one was if he multiplied the smaller one by 2, then it was less than 2 times the smallest. The largest one was less than 2 times the smallest.
Right.
So I'm a little bit confused because then the third one says the largest sample mean is less than 2 times the smallest sample mean.
Okay. Let me
So
see.
I don't know. I guess we kind of either. I guess that means we need to research it, right?
Yeah, we could just answer the different answers that we have and see.
Yeah.
But I don't really have. Mine was just more of it made the most sense to me, not that it was in any of the rules. So yours makes more sense.
I don't know.
What's that?
Is that what it said in the book? The 4 times thing?
I'm checking one more time just because I don't remember. I was more focused on the ANOVA stuff, like the SPSS. Oh, I need to sneeze. Thank you. Thank you.
Okay. We assume the variance in each group is the same. Okay. If the largest variance is at least 4 times as big as the smallest variance, we will conclude that the calculation variances are not equal. If the largest variance is not 4 times as big as the smallest variance, okay.
Yeah, you're right. You're right. It's if it's less than or 4 times the smallest variance, then we'll conclude the variances are equal. You're right. Good job, Shuri.
The second one?
Yep.
Okay.
An ANOVA hypothesis test is equivalent to conducting independent 2T sample tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1 to 2, 1 to 3, and 2 to 3. How many pairs are there when there are 4 samples? Okay, so this one I didn't understand, and he drew it out for me, and it made a lot more sense. Hey.
For that one, I think I fixed it, but I don't know if that's right. I want to see how he showed you.
Okay. Thank you so much. All right, I have no idea if you're going to be able to see this. I took a picture of it with my phone because I was like, that is a great visual image. But it's really small. So, can you see that?
Yes.
Okay. So, he said that you just count so the reason it's 3 is because it's 1 to 2, 2 to 3, and 2 and 3. 1 to 3. 1 to 2, 2 to 3, and 1 to 3. So it would just be the 3 lines.
Okay.
And then for 4, it's 1 to 2, 2 to 3, 3 to 4, and then 1 to each of them, 2 to each of them. So it'd be 1, 2, 3, 4, 5, 6.
Okay.
So you were right, but mine is visually makes sense to me.
Way to do it. If you get it, that makes sense. You went right.
Yeah, that
That
one made sense to me, so I was very happy with that. Oh, we gotta open another data sample. I didn't see that. Darn it.
Alright, so now we're on 8. So, this is when we just plug in through.
Yeah, we gotta do the soccer shoes.
Mm-hmm. Okay, the p-value is the detailed thing, right? And it's the best remember.
Say that again.
You know how like the p-value isn't labeled as the p-value on SPSS when you like do stuff?
Yeah.
What is it labeled as? Do you remember?
I feel like when you look up the p-value on SPSS, it's under the whatever like where it tells you what the tail is.
Okay, cool. I just want to make sure.
That's what I think.
No, that's right because I was like, that's what I thought. I need something to confirm it.
Okay. So am I right that for this we're just gonna do normal descriptive I'm just struggling with words today. We're gonna do normal or no, we would do compare means in order to get the p value. But we're not doing one way ANOVA, right? Or are we?
I did keep the one way ANOVA because it does show you that as well. If you go into so if you I don't know if you have to transform it first.
Transform it first.
So you know how to do that?
No.
So you go.
Is it computing the variable?
It is. So it's just to make it so you can put it into the ANOVA. Because then if you try and put it in the way that they give you the stuff, like the data, it doesn't work. So you have to go to transform and then do push automatic recode.
Oh, okay.
And then you have to like add a new name.
So it would be footwear, right? Footwear would be the variable.
I just put in I did it before. I'm trying to figure out what I did. I just typed in like the new name was like shoes. And then I pushed add new name. And then I pushed OK. And then it brought up, and then I went to analyze, compare means, one way ANOVA. And then the new factor that you made, or the new one that you made, you put the factor, and then you can have to Those in the dependent means.
Okay. I don't know if mine did it correctly. Does it show? So
Did you push
So-
the options? Like on your, are you on the one-way ANOVA one?
I just barely finished automatic recoding. Wanted to make sure I got it right. So I have the shoes column, which is right after comments. And then for A, it goes 1, and then B2, and then C3, 4.
Yeah, that's right.
Okay, so now I can do analyze, compare means, one-way ANOVA. And then I would pick shoes, not kicking accuracy, right?
You would do the kicking accuracy in the dependent list, and then for your factor, you do the shoes. And then you go to options before you push OK,
Okay.
and then push descriptive and then means plot.
Descriptive, and then you can continue.
Do the means plot, the one that's underneath the, that one that's like kind of by itself.
Oh, means plots. There it is. Yeah. And then continue.
Yeah. And then you locate it. And then
Aha. Okay. See, I need somebody who knows how to do that stuff, and I need him to teach me that. It's good to understand stuff, but I also need to understand SPSS.
The only reason I can do SPSS stuff, I can't ever grasp the SPSS stuff from reading the book. I have to watch them do it on the video.
Sometimes I have time to watch the videos, and sometimes I don't.
Oh, I totally understand. Tonight, I was just like this. I was like, I need to look at my review, and otherwise, I won't be able to. When I read the book, I just don't get it.
Seriously, the book is like a foreign language.
Yeah, it's pretty. It's just hard.
Oh my goodness gracious.
I hear that.
So,
All right, so then it tells us that the. Oh my gosh! Hi.
He's really enjoying himself.
Yeah, for some reason, cats really like hampers. Can't figure that one out. All right, so it tells us the p-value is going to be 0.0809.
Right.
Does yours say that?
Yeah. Well, mine was rounded. Find my data now. I can find it.
0.0.
I have a long list. But it was in the significance on the right. You see that box?
Mine just says 0.081, so mine rounded too.
So then you got the right one. I already think you got the right one. So then
Okay.
it's asking if you remove the SOX data, what the p-value is.
So you just got to redo it and take out the SOX value.
So what I did is I just cut, I just took the SOX value, and then I cut it, and then I redid the test. I did the,
You redid the ANOVA?
Yeah.
All right, so did you just like grab and drag down and like delete?
I right-clicked and cut it so that I could put it back.
Oh, that's smart. Good call. And you just cut the SOX, or you cut the numbers too?
Let me look at it. I think I cut all the way across. Like I cut SOX, and all. Yeah, I did SOX and all the numbers that correlated with SOX.
Gotcha. All right. So did I, and then we'll go analyze, compare means, one-way ANOVA. Options are still the same. Continue. Okay. And did you get that the p-value was 0.309?
Yes.
Sweet.
Congratulations.
I really like it when we get the same thing.
Right?
Because then I don't have to sit there and go, crap, what did I do? Wonderful. Alright. Number 9. P-value always goes up when only one group is removed, compared to the p-value when all the 6 samples are included. I said that was true, but I said it was true because Trevor explained it to me, but I don't remember what he explained to me.
So, I said it was true too, and I justified it in my mind somehow, but I don't remember how. Mostly because I think I was just looking at the one frame rate and I think, well, that one went up, so why would the other one? So,
Yeah, and it went up a lot, so my guess. I think I remember how he explained it. Okay. So if you picture the circle thing, graph, distribution. If you picture the normal distribution and you picture the p-value area, and the more data that we have, the more it spreads it out. So if we take one away, it covers more area is gained, I think, is how he explained it.
Okay.
Does that make sense?
So he said it's always true?
Yes.
Okay. Well, we'll go with that then, because it sounds like he knows his stuff. Right?
Say that again.
I said, we will just go with the true then, because it sounds like he knows his stuff more than I know my stuff.
Oh, dude, he knows his stuff more than I know mine. He's whipping out that graphing calculator, doing stuff while I was trying to make my SPSS do it, and I was like, why do we have to learn this when you can just do it on a calculator?
Well, if we can type stuff in, why am I trying to compute this on the computer?
Yeah.
Okay, so for number 10, it's asking what the highest p-value is when you remove only one of the groups.
What is the highest p-value you see when
So this
removing
is
only?
what confused me a little bit for number, in comparison to number 9. So I went through and this is the very last one I got to, by the way, so don't count on me going very quickly on the next one.
Okay.
So for number 10, I cut, the first part of the data out, like all the A's, and then did the ANOVA test, and then and then put it back, did another test with all the B's gone, right?
Right.
So that's basically, I'm pretty sure that's what it's asking me to do.
Yeah, I think it is too.
So,
Did your p-values always stay higher or no?
see, that's what I don't think. Let me see if I can share my screen really quick.
Okay.
For you
Okay.
what I got.
By the way, kudos to us because we are still live and it has not dropped the call once.
It is working.
It's a beautiful thing. You should savor the moment. Oh, I should stop talking. Okay.
Okay, can you see?
I can.
Okay.
If I don't talk.
So here's the first one that I did with B, C, D, E, and stop right here. You see it like right here.
Mhm.
So then here's the p-value, right?
Right.
It's 0.060. That's lower than the 0.080, whatever the right?
That is lower. Yeah. Well, that shoots Trevor's theory in the foot.
And that's the only reason I'm confused. Because in my mind, when I was looking at that question, I was like, oh, look at this. So we see this one. This one is 0.052. This one is the highest one I saw, but I want to make sure it's 0.448.
Mm.
This one is 0.031. 0.050 right here.
Yeah.
And
Maybe the reason is then, maybe what it is it can't always make it higher because there's a different amount of numbers in each of the variances. And so you never know what's going to happen when you take out one section.
right,
Maybe it is false.
so it's different data, right?
Yeah. Yeah. It really depends on your data.
Yeah, so that's what I'm thinking. So the highest one I saw, so to compare that for number 10,
Mm-hmm.
the answer that I got was this one, the 0.448.
Okay.
I mean, assuming that I did all the stuff right.
I'm sure that you did, Shri. You are actually a very capable statistics master.
Oh, I don't think so. That's why I got a D plus in last week.
His D plus is higher than what I got. Just saying.
So, you know. He's like,
Statistics is hard. I don't think anyone truly understands statistics.
my husband understands it, and I do not know how. I wish I understood. Okay.
Yeah. So the .4481 was the highest.
Yeah, that's the one that I thought it was the highest.
Do they want the number .448 or do they want... Oh, they do. Okay, they do want that. Okay.
Yeah, they want the actual p-value.
Yeah.
Okay.
Then for the smallest one, that one would have been the 0.21 or 0.31. I don't remember. Or no, it would have been 0.06, huh?
But it says like when all 6 samples are used, what is the smallest, what is the minimum variance?
Oh, wouldn't that just be the first one? Oh, no. Now I see what it's asking. So it means when all of them are used, the smallest variance.
Well, isn't the
Not the smallest p-value. I'm getting confused in my head.
oh my gosh, that confused the crap out of me. Okay.
Me too. The smallest variance. So the smallest variance.
Okay, I gotta redo my
Smallest variance. Variance is not another word for p-value, right?
The variance is
Because I'm thinking in my head that it's the p-value, and it's not the p-value.
is it standard deviation?
Maybe it is. Ah, crap.
Yeah. Variance is the square of the standard deviation. Sample variance is equal to
Shoot! 1 second. I have made a boo-boo.
Okay.
Please fix it. No, don't do that. I'm sorry. Whatever happened, I'm sorry.
In the book, it says the variance is the square of the standard deviation.
Oh, so you have to square the deviation. Okay, so it wants us to add all of it up. No, not that. Hang on. Let me think through this. It wants us to do so put all of it back in, and then do the analyze the ANOVA, and then take the square root of that standard deviation.
Square? I think it multiplied by 2.
Say that again.
It says the square, so I think multiply it by, or multiply it, you know what I mean, like.
Like square. Don't square it. Like square it, but not square root it.
Right.
I get you.
I am like not good at explaining things.
I just problems with words in general. No worries.
I'm a little out of it. Okay.
Okay. Alright, let's do that then. So, hey, don't do that. Come on now. I pissed mine off. Did something to make it mad.
Okay, so we're trying to find the smallest and the largest variance, right?
I think so. Yeah, what is the minimum? What is the maximum? Please don't do this to me. Please. No, that's not what I want to do. Dang it. Just come back over here to the side where everything is beautiful. And good.
Okay. So minimum. So the smallest one I got.
Don't tell me yet, because my SPS got really ticked off, so I had to
I had to redo it.
yeah, I had to redo it. So it's opening back up for me. Ah. Almost there. Okay. Okay, did you get 0.006561?
No, technically no.
No, but I might have.
Hold on. Wait, let me go back up for a second. Okay, we're going off of. Oh. Okay,
Oh, I did the p-value instead of the standard deviation.
we're going off standard deviation, right?
Yes. Okay,
So
let me try again. Okay, so the highest standard deviation
Yeah, go.
is D.
When you're done, I'll explain how.
Okay, thank you, babe. 7.291.
Hey.
Alright, so you take the highest standard deviation, which would be D, right?
yeah.
And you, I got 53.5. 15, 86, 81. Okay, so that would be the, oh, whoa, whoa, whoa. That would be the maximum variance, right?
Yeah, 53.159.
And then the smallest standard deviation is A.
Yeah.
So 5.
No.
Oh, it's not.
C.
It's C. Oh, yeah, it is C. Good call. 2, 6. 27.207.
Yeah, that's what I got.
Nice. Okay, so the test for equal variance is satisfied for these data.
I put 12.
Huh?
I said I put 12.
Yeah, because they're not all equal.
Yeah, they're like
Yeah, they're all over the place.
So now for the QQ plot.
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see. Oh, okay, so we have to create QQ plots for each one and see if all of them are normal distribution.
Right. So
That's exciting. So would we just like click a column and drag down to the end of it and then analyze it with, or graph it with the QQ?
Yeah, because I've been trying a few different ways, and I just am not getting it to work the right way. I don't know how.
What did you try?
So I just tried all the data until it was separated, and it didn't separate it, right?
Right.
So then I was like, right now I'm trying to select just A to see if it'll. He did it on the supplementary video, and I know how to make the QQ plot. I just don't know, like, if
How to separate the data?
yeah, if I'm putting the wrong variables. You know what I mean?
Yeah. I'm trying it with I'm just trying to like drag down and see how that goes.
Yeah.
It might not go well. There's a possibility. Give it a shot though.
I do not know what I'm doing wrong. This is so frustrating.
Okay, kicking accuracy.
Because it should be like one of the
That's
easiest
not
questions.
shoes maybe? Maybe we do want kicking accuracy. We probably do. I want shoes too. Where's footwear? We actually like really need footwear.
But it should show us like 5 or 6 different QQ plots, right?
It should, yeah.
And that's why I'm not.
Alright, so when I did mine, okay, that's cute. Okay, so I got 1, 2, 3. It just did 3 for me, not 6.
Man, I don't know. I really don't know what to do because
Analyze descriptive data. There must be something that we do in here, like we have to transform it or something. Natural log to transform. What do you think that does? Or standardize the values? Difference?
I'm trying to.
Seasonally different?
He did it on the video and he made it look like it was so easy. Dotty dotty dot, you know what I mean?
Yeah.
Like, don't do any extra stuff.
Yeah, I totally get what you mean. Sometimes I watch the videos and I'm like, I got this. Then I try to do it. I don't got this.
Yeah.
It's kind of my life. I don't know what that would do.
Here we have the QQ plot for B. And it,
Sorry.
Oh, no, you go. Are you gonna watch the video?
I was looking at it, but I don't know if it's the right part, and I don't want to he has a QQ plot pulled up at the start, but I'm trying to figure out where it shows what to click on to get it. Mhm. Um,
That does not seem right. That does not seem right at all.
code. Now, if we come up here, we can do analyze and compare means. And now, one way ANOVA, we'll see that now we have type code. Now we can put that in. Before we do that, let's do analyze descriptive statistics and explore, right? And we want to do our calories independent, type code in the factor list, and let's go to plots. And we want to do normality plots tests. So we want to see a QQ plot for each of these.
Okay, that's how we
Click
did it.
continue.
Yeah, what did we click on? Let's do explore.
Went to explore.
Okay, analyze, statistics, explore, and then you put each of the things in like the dependent list. Let me watch another part just to see if I can compare it with the part.
Okay.
Right? And we want to do our calories independent.
Okay, so we're going to put the cooking accuracy in the dependent.
Put where in factor list? Or label cases by?
Are you in explore?
Yeah.
Oh, in the dependent list at the top. So you put cooking accuracy in the dependent list on the top box.
Right.
And then let me see what you put in the next one.
The type code in the factor list.
Okay.
And let's go to
So the one
plots.
that
And we want to do
made.
normality plots tests. Because we
Hold on. And then the one that we made, the shoes one, we put in the factor list.
Oh, okay. I got those two mixed up then.
And then I have to go back a little bit and see what you pushed. Because I didn't stop it quick enough. Okay, then he pushes plots.
Which one? Like he clicks the little button plots and like marks it, or he clicks the option plots?
He clicks the option plots on the right there. Does that make sense?
Yeah, so like the one that's right below statistics.
Yes. And then
Okay.
he clicks, let me see.
and let's go to plots. And we want to do normality plot tests. Because we want to
Okay.
see a plot for each of these.
Okay. Normality plot, continue, okay.
On the bottom with display, do you click plots? I think you do, don't you?
Which one?
So at the bottom of Explore, it's got display, and then it says both statistic and plots. Do you do both, or do you just do plots?
Just plot.
Okay. All
Oh,
right.
wait. I don't know. And plots is what we're looking for, so what is it?
Hey, it worked, Shri. It worked. That's exciting.
Those videos save me.
Okay, so I'm gonna guess from looking at these that it is not They're not all normal. There's some problems here.
So the normal one says A, B, C, D are normal, and so is E. Oh wait, they all look like they're normal. They don't all look normal to you?
Oh, they do. If you keep going down, there's some funky ones, and I was
Yeah,
looking at the wrong ones. But yeah, they all look normal.
Okay, good. So we are on the same page.
I started from the bottom and went up, and I was like, what? Crap, these are not normal. But yeah, each of the samples are normal based on what you see in the QQ plots.
Okay, so, now 15. The test statistic for ANANOVA hypothesis test is an S statistic. If the p-value, the area, to the right or to the left of the S statistic.
Is the p-value the area to the right or the left? That's a good question. I'm going to go read that again because I don't remember.
Yeah, are you looking in the book too?
Yeah, the test statistic in an ANOVA follows the F distribution. This is the first time we've encountered this distribution, blah, blah, blah. For the ANOVA test, we use the F statistic. The p-value for the ANOVA test is in the right tail. Correct.
That's what I thought.
Nice.
Okay, I am going to submit.
Alright, let's submit this puppy. Ooh, Shuri, I'm seeing a lot of green.
Gotta be plus.
Ah, we missed number 9. Dang it! We were wrong. After all, oh no, I just never changed it. Dang it!
Oh, I forgot to change it too.
Dang it!
I did the same exact thing.
We figured it out and then forgot to change it.
Right. And then for 13, S for equal variances is satisfied.
Oh, it is?
I guess it is because so we're just, you know, when you check the two things,
Yeah.
you just need, sorry, you just need to check. It's not if they're all the same. You just need to check to see that one of them's not like double the other one or 4 times the other one, right?
Oh, that's right. We didn't follow the rule.
But at least we know why we got it wrong, right? And it's not like last week I had no idea why I got it.
Oh yeah, last week was horrific. Last week was horrific.
Yeah, I have to like go over all that stuff again to be able to pass it off.
Yeah, me too.
Okay, so we are good for tonight, right?
Yeah, we are. Shuri, check that out.
Awesome. So I am, now I have like 30 other assignments.
Yeah, I got 2 more classes to do homework for.
I'm glad I'm not the only one.
But at least we have this out of the way. You know what I'm saying?
I know exactly.
That's a blessing.
So, okay, you work on Wednesdays, right? So you won't be at the group meeting.
No, I'll still be driving home at 5:30.
Okay, so we need to do our group meeting. So the group meeting is like Friday, which is no big deal. We'll just do our normal meeting on Thursday.
Right.
Does that work?
That works for me. So, are we gonna meet? So, I know we always say we're gonna meet at like 7 or 7:30, but then like get down to it and I'm like, don't have enough time. So, do we want to try for 7:30 and then
That's fine.
if we need more time, we can. Kind of the nice thing that it's just you and me is we can kind of work with the time because you're a mom and I work.
So you want to do 7:30?
Yeah, let's shoot for 7:30 and then if we need more time, we can just work from it.
Sounds good to me. We'll do it.
All right, I will put this video on the group collaboration.
Thank you.
All right, have a good day.
Talk to you later.
Bye.